It does happen that to some degree in the Pacific, in the closed basin and in the Indian Ocean, but in the Atlantic, that is a very different pattern. And clearly in the Atlantic, warmth is captured from the southern hemisphere and moved into the northern hemisphere. So the northern hemisphere is as warm as it is because we trap and bring to the northern hemisphere heat which originally went into the southern hemisphere. Now that's an interesting concept because it means that when we look at past and future change, the northern hemisphere relies on heat not just occurring in the hemisphere, but also its ability to trap this heat from further south. And we'll see when we look into the Agoulas paper a mechanism for how that actually operates. So at a global level, that's really quite an important finding, that the northern hemisphere cannot, although it can be treated as a uniform atmospheric unit, cannot be treated as a uniform oceanic unit. It takes its heat from somewhere else. If the thermohaline circulation shuts down, then overnight, of course, this is what the day after tomorrow suggested was going to happen. We were all going to freeze over. What causes that is, ironically, you melt the ice on Greenland, you melt the ice where in northern Canada, and you pour cold water into the North Atlantic. If you pour cold fresh water into the North Atlantic, it will freeze, and it will therefore reflect, increase albedo, and for a short time it will push the system and be stronger than the heat that's coming up from the north and stop and break down the conveyor belt, and we'll all freeze over. So one of the net potential effects of global anthropogenic climate change is that we will get colder. And for a time, if the thermohaline circulation breaks down, we could freeze. We could quite genuinely freeze over and have a period, not quite sure how long, of significant cold. A sort of little ice age plus, if you like, probably more significant than that. This is why when the thermohaline circulation, or the AMOC, is shown to slow down, certain alarm bells ring and saying, is this a precursor of the fact that actually there's so much melt going on in the Arctic, there's so much freshening of the northern seas that we're likely to shift into this cold phase. And we know that in the past, some of our coldest periods, the thermohaline circulation effectively broke down. There was no deep water formation. But it will, in the future scenario, it will not last that long, because once that ice has melted and you're not putting all this fresh water in, there's not enough fresh water left, the general heating of the atmosphere and the general amount of energy and heat that's available in the Earth's system will suddenly take it off again. When you then take it off and you melt everything, there will be a rapid rise in temperature. So you can imagine how we get into a positive feedback of lots of melting of Greenland. Greenland melts, just like that. Well, you can't do that. Let's say a lot of it melts just like that. Fresh water into the North Atlantic, everything freezes. And so you get significant amount of freezing and cooling. But you're still getting melting going on because you've got some surface melting, etc. So you get a short period of really, really cold conditions. But the heat is still around in the Earth system. Greenland's gone, or significant amounts of Greenland's gone. So suddenly that heat takes over and just clears the ocean of this thin ice, and all that heat's available, and then temperatures really rocket back up. So this could be a really this has come and gone as a sort of abrupt, rapid climate change potential scenario as to whether you're worried. So you'll see in the IPCC reports, they give an idea of whether they think it's likely that the THC will break down or not. And at the moment it's pushed as it may happen next century, but not this century. That's the sort of thinking at the moment. So, that's the reality for a short period in the future, if it were to break down. So polar water gets warmer, less dense, most warming at poles, less ice formation, deep water ceases. Because once you do shut that down, it will actually break. So it's a sort of mix. You're freshening it up, you're stopping the deep water, that's cutting it off, you're not getting that meridional transport, no THC. But eventually that will break down. I won't go into that, I've just been through most of that. Of course, what also happens is that water is the oceans are very important in the world's carbon cycle because it does transport the carbon from the equator